congruent figures. What does congruency mean? Like, without even looking in the book, what does it mean if we're talking about things are congruent? Okay, they're the same, right? So we have looked at, like, segments, right? We've talked about congruent segments already this year. I can't remember now if that was chapter 1, chapter 2. It's probably both of them, to be honest. But we have talked about congruent segments. Well, now we're just going to look at our congruent figures. Now, congruency, remember this symbol? Don't forget that that little equals with a squiggle above it shows us congruency. So yes, they're pretty much the same. They have the same size and the same shape, but we don't put an equal sign. We put a congruent symbol, which is the equals with the little curve above it. Now, they list out here congruent circles, congruent polygons, and then congruent triangles. They're all on this page in those little blue boxes. But all of them are the same idea. Congruent circles need to have congruent radii. Therefore, they're going to be the same shape and the same size. Congruent polygons, they need corresponding sides and angles to be congruent for them to be congruent. And the same thing's true for triangles. Congruent triangles, they need corresponding sides and corresponding angles to be congruent. So, if you're looking over here at these two triangles, we have two triangles that are congruent because they have shown us that AB is congruent to what side? What side is AB congruent to? Okay, so I'm going to write ED here and then I'm going to write DE. One thing that is important, and you have to pay attention to this because you're going to get counted wrong if you do not write it correctly. If I write AB, then my other side needs to correspond appropriately with the letters. What letter corresponds with the A? Huh? Look at your tick marks. D. So I have to make sure to put D, E over here. But if I had said BA, what should I write? I should write ED. You have to make sure to write them correctly. Do y'all see why those two things have to be written that way?
Because
Right, like that, this bottom triangle, it's like you rotate it up, right? Rotate it 90 degrees, and you'll get it to land on that top one. Now, not only that, but also looking at the angles. What angle corresponds to angle A? If I say angle A is congruent to what? Angle D. But angle B is congruent to angle E. And then I might as well finish it out. Angle F is congruent to which one? Angle C. So when you're looking at naming and stating congruency here between triangles, and really any shape, but the focus of this chapter is on triangles, so that's the main thing you're going to see. You have to make sure that you state them in the right order. Obviously, for the angles, it's one letter, but that angle letter helps you in identifying the sides. Because if I said side FE, what should I say it is congruent to? FE is congruent to what? CB. I can't say BC, because if you say BC, then you're saying that B and F correspond to one another, and they don't. Now, you've got the angles, you've got the sides, and you also can say the triangle itself. So I can say triangle, I'm going to go with ACB. Because the order doesn't matter as long as I'm going clockwise, counterclockwise, starting with one of the letters. So if I start at A and say ACB, what am I going to say it is congruent to on the other triangle? What letter has to go with A? D. What letter has to go with C? F. And then what letter has to go with B? E. Now, are there other congruency statements I can make there? Sure. What if I said triangle BAC? What's it going to be? BAC. What did you say? EDF. Does everybody agree with that? Yeah. So, my whole point with this here is that you are going to be asked questions about sides that are congruent, angles that are congruent, triangles that are congruent. The statement that you make has to match with what that picture tells you. So does everybody see why I can't say side AB is congruent to ED? Does everybody see why that is a bad statement? Yeah? Okay. Because I don't want you to make those statements. I get that you're saying those two sides are congruent. You recognize that by the tick marks, but you're not recognizing the angle that matters also there. So, everybody good with that? Okay. So don't get upset when Miss Bass counts it wrong if you're not getting clarification now. All right. Now, this can be for any shape, like I said, which is why they have listed here congruent circles or just congruent polygons. We could be looking at a quadrilateral, a hexagon, heptagon, whatever. It doesn't matter. The same rule applies that we've got to look at the tick marks, look at the angle markings, and see what is congruent and what is not. In your textbook, you're going to see questions that say, state the triangle that is congruent to, just like I did, of BAC. And Savannah said EDF. She looked at the correct order. So you're going to see that as well. Same thing with side measurements, or side lengths, whatever. So just make sure that you're matching those appropriately. All right, I'm going to go to example 1. I'm going to look at a couple of these examples, which are just really more or less looking at the congruent parts. And then we're going to do one that has more of a solving that's not in your book, but there are homework problems that go along with it. So, example 1 says, a scissors truss can be used to support a roof when a sloped ceiling is desired. So that's that little X that's in the middle. If triangle UVW, so look at the order there, UVW is congruent to triangle YXW, list all the congruent corresponding parts. So here with this, they don't have any tick marks over there on that picture, but they don't have to. They said that I'm going to write it above here so I can zoom in. Whoops. UVW is congruent to triangle, what did they say? YXW. So if you're someone that visually needs to see that, then you need to go to your picture, or I'm going to show you in a minute that you may not get a picture at all, and that's fine. What you have to realize here is that U goes with Y, V goes with X, and then obviously you've got your W and W there. So I can put a curved line here for U, and then I'm at Y. And then I could put one at 2 at V, and also at X. And then obviously this one here is much more obvious with W, because what is that? What are those angles? What are they called? Vertical angles. So we know that they have to be congruent, right? But if you need to draw that in, then draw it in. But what does that mean? So I've got angle U is congruent to angle Y. Like that's what the question is asking you to do, to list them out. Angle U congruent to angle Y, angle V congruent to angle X, and then angle W obviously congruent to angle W. Now, with the sides though, if I say side VW, what are you going to tell me it is congruent to? What is VW congruent to? XW. And what is, where am I at? YW congruent to? UW. Okay, I could list them all out. I'm not going to list every single one. But we get the picture there, right? All right, and then the last thing would be just your triangle itself. So if I say triangle VW, what's my letter over here? U. What is VWU congruent to? Which triangle? XWY. Okay? So being able from any picture which, like I said, this picture wasn't labeled with tick marks, but it doesn't have to be. We have to be able to take the information where it says that triangle and show that they are congruent. Now, example 2 does take that picture and says, find the measure of angle X in that example. If, once again, the triangles there are congruent. The measure of angle U is 22 degrees, and the measure of, and I'm going to write that in, this here is 22 degrees, and then what did they say? UWV is 30. And they've asked us to find angle X. Well, there's a couple of ways to look at that. But one of the easiest things is to say that angle X is the same thing as what? What letter? Angle V. So therefore, I can take these two, add them up. What's 30 plus 22? 52. And then subtract that from what? 180. And that's going to give me angle V, which in turn is also giving me angle X. Okay? And it's what? 128. Okay, so 128 degrees. So all that is tying back in what we know about a triangle to be 180 degrees. Now, for something that is not in your book, these two examples. I list out a triangle. And so you can't look in your book for this. You're not going to find it. So if you want to jot something down, jot it down. But you're going to see homework problems that deal with this. So for that first example, it says triangle LMN is congruent to triangle PQR. Now, if you say, I need a picture, then draw yourself two triangles. I don't care. But you don't have to have a picture for this. If you will recognize L goes to P, M goes to Q, N goes to R, right? I'm not distributing there. I'm showing that those are the ones that are congruent, right? So please don't confuse that with distributing. I'm not distributing something. I'm simply saying that L matches to P. But if you would prefer to draw yourself a picture, LMN, and then have yourself another triangle that says PQR, by all means do it. L and P, M and Q, and then N and R, right? Like, my picture's not amazing, but it shows what it says. So if you need a picture, draw it. But they tell us that N is 8A plus 6 and R is 10A minus 2. I don't need the picture to say that the triangle congruency tells me N and R are congruent, right? In just this statement here, it tells me that N and R are congruent because they're in the same placement. So I don't need the picture to show me that. I can simply take the information in this and say 8A plus 6 must be equal to 10A minus 2. I'm not doing anything with 180 degrees here because I don't have a third angle, right? I only have two angles and they are equivalent to one another. So I set them equal and I solve. But what did I ask for here? Do what? A equals 4, but that's not what the question asked for. The question said to do what? Find the measure of N. So, N was 8A plus 6. What is the measure of N? Someone do some math and tell me. What is 8 times 4 plus 6? What's 8 times 4? Okay, because 8 times 4 is what? 30? You're killing me here. What's 8 times 4? 32. Okay. So, this is 32 plus 6. But yes, it should be 38 degrees. Mm-hmm. And isn't it, right? 10 times 4 minus 2? 40 minus 2? They better be the same, right? If they're not, there's a problem there. So, yes, you can check both of them, and they better equal one another. All right, I want y'all to answer this second example on a sheet of paper somewhere. Jot down what you need to answer this question. I'm not writing anything up. I'm giving you a minute to answer it based on what I just did on that first example. I think that was Mr. Alter.
I think it was too.
Yeah, no, it's Mr. Alter. Same thing, if you want to draw a picture, by all means do it. But look at the order in the letters here. B to C has to correspond to E to F. So what should you be doing with those two expressions? What should we be doing with 3 times x minus 6 and 5x plus 20? Set them equal. If you haven't done that, go ahead and start. Oh, I didn't mean for that to be a negative number. That was supposed to be 5x minus 20. Do apologize, y'all. That was supposed to be a minus 20.
Happens to the best.
I know. My answer was supposed to be x equals 1 when I put that on there earlier. Yeah, I'm very sorry.
Yeah, I got negative.
Yeah, and it doesn't make a lick of sense if you do that. Because you have a negative side length. My bad, y'all. That should be a minus, and you'd be adding 20 over. I wanted that to be a positive 2 and a 2x. So if you can just change your sign ever so slightly. Now, I'm not saying that the x value couldn't be negative, but based on what I made my expressions to be, a negative x value would not make sense because it wouldn't turn it back positive for that length. So that was something to think about there. But now, that's still not a good x value. Let's just say we're going to stick with finding x. Okay? Don't find the length side BC because that number's no good either. No good. You're going to get a negative answer whether you use that negative. What did you have? Negative 38 divided by 2. Was that what y'all had?
Yeah.
Yeah, so negative 19. Still wouldn't have given you a good answer. 1 doesn't give you a good answer. You still get a negative answer. So just ignore that piece. We're going to stop at x equals 1. Okay? Minus the negative side, because you're ignoring that. Does the solving make sense there? Okay? So all of this here is all about your congruent segments. Whether you have congruent angles, congruent sides, congruent triangles, you get all the other ones within that. So you've got to be able to make your congruency statements, and you've got to be able to solve for missing pieces from those. So, these three things here all say the exact same thing, so I was going to say it briefly. Triangle, circle, and polygon congruence all are an equivalence relation. It's just showing you equivalent sections. And then, that was all. I'm not worrying about those polygons there. So, in your books, on page what page is this? 159. I'm going to give you some problems to look at. All right, so you're going to do number 6 and number 10. Number 6 is listing out congruency statements. It's not multiple choice, okay? It's A through F. You're listing out what is congruent. Number 10 is stating, and now number 10 could be multiple, like y'all all, not all of you, but 3 of you obviously could give different answers for how you list this one out, because number 10 is asking you to make a congruency statement for the triangle. Are you going to say triangle ABC is congruent to triangle DEF? Are you going to say triangle XYZ is congruent to whatever? That's all number 10 is asking you to do. But what Sammy puts down, what Lauren puts down, could be 2 different things, but they can still both be correct. Then number 13 is using correct notation when they have switched the order of the letters to match it to that other triangle. So there's not solving involved with that one. It's just a matter of recognizing those relationships. And then numbers 19 through 27 are more of your actual solving for values. And I think I want you to look at number 40. Now, number 40, you need to make sure to read what it says above there, that point E is the midpoint of AC and BD, because if you don't read that section and think about that on that picture, you're going to say, I don't have enough information to answer this question. So on that number 40, I'll go over here to it, make sure you read this piece of information to be able to make markings on that picture. Because you're going to look at that picture and say, they've only told me that one thing is congruent. But that's not true. You have parallel lines and a transversal also. So you have angles that are congruent based on those parallel lines and transversals. So with this picture, I'm going to see, do we understand things that we've talked about from last chapter and how they still apply to this picture to answer this question. So you're going to answer question 40 with that.